students, today I am going to discuss a topic that is about series as well as parallel. Series parallel resonant circuits. In this we are used to take three combinations, that is resistor, another one is inductor, another one is capacitor. In this, if three elements are connected in series, then it is known as series, whereas three elements are connected in parallel, and it is known as parallel resonance circuit. When will be occurred at the resonance? Nothing but if you take in a circuit, if you given an input, similarly we are getting an output. Okay. If the input voltage is tunable at particular frequency, then we are getting the output is known as resonant frequency. అంటే nothing but applied voltage to the natural frequency, then it is known as resonance. A resonance can be obtained because of both elements of inductor and capacitor, nothing but inductance and capacitance. Both are used to store energy. Okay. In series, you used to get minimum impedance as well as maximum current flow. You are used to observe, as well as the maximum admittance. Whereas in parallel, you can say that maximum impedance as well as minimum current flow. It can be entire LCR series resonance can be acted as acceptor, whereas LCR series can be acted as rejector. Okay. This is about basic introduction. Now let us know about series impedance. I mean series LCR series resonance circuit in brief. For that, I am taking the circuit as resistor and inductor, and again I am connecting with a capacitor. I am simply applying a voltage source to the circuit, nothing but R, another one is L, another one is C. Okay, this is about series resonant, nothing but V0 into sin omega t. Okay, L means inductor, already know. The reactance of an inductor can be represented as XL, nothing but J omega L, whereas C means capacitor. The reactance of a capacitor XC, nothing but 1 by J omega C. Okay, nothing but in this the elements L, C, R are connected in series, then it is known as series resonant circuit. Okay, for that, measuring the impedance Z is equal to R plus J I mean reactance of an inductor XL plus XC. I am taking in terms of image terms J omega L plus 1 by J omega C. This can be written as J will be common, omega L minus 1 by omega C. Okay, this is frequency independent term, whereas this is frequency dependent term. Okay, in order to obtain resonant frequency, the imaginary term is equal to 0, so that omega L minus omega C is equal to 0. Omega L is equal to 1 by omega C. That can be written as omega square is equal to 1 by LC. Omega not square not తీసుకెళ్తున్నాను 1 by root LC. ఓకే, ఆల్రెడీ ఒమేగా అంటే మనకు ఒకటి తెలుసు, ఏంటది? 2 pi f. 2 pi f is equal to 1 by root LC. f is equal to 1 by 2 pi root LC. This is the frequency of series resonant circuit. Okay, in this we are used to obtain maximum impedance. Minimum impedance can be obtained in that minimum impedance. What you are telling in series resonant circuit, I derived a frequency, as well as it can be derived by using, it can be, the graph can be explained by taking frequency along x-axis as well as gain along y-axis. I am obtaining a graph like this. This is the maximum gain I am getting. I am represented as omega r, nothing but resonant frequency. For that I am its current will be maximum. Okay, the bandwidth can be determined as, it can be determined as energy stored as well as maximum energy stored as well as dissipated energy dissipated. Okay, this is the derivation of bandwidth, whereas it can be derived as a quality factor. Bandwidth means it can be different between two frequencies, nothing but upper cutoff frequency f2 as well as lower cutoff frequency f1. Difference between two, nothing but it can be written as delta f. Okay, at a time this graph is used to depend upon selectivity, as well as it can be determined by using two parameters. First one is quality factor and another one is bandwidth. This is about series resonance circuit. Entire it can be used in band pass filters for tuning, as well as voltage regulations, as well as in telecommunications, as well as in radios, as well as it can be used as frequency selectivity also. Okay, in tunable circuits also. This is about a series resonant circuit. At a time the power factor can be represented as, it may be unity, nothing but it may be represented as a cos pi, that is equal to r by z, that is equal to r by r, that is equal to 1. Okay, this is about series resonance circuit. Now we come across a parallel resonance circuit. For that the same circuit has been used, same that it is also give the maximum current flow to the circuit. The frequency as well as same circuit I am been taking, but the values are been reversed. Okay, this is about parallel circuit, parallel resonance circuit. Okay, in that in this also we are having total admittance we are deriving, that is 1 by Rp plus 1 by L, nothing but reactance of inductor, plus 1 by Xc. 1 by Rp, 1 by XL means 1 by j omega L plus 1 by omega j omega C. Again 1 by Rp plus I am taking the common as omega L, nothing but 1 by omega L minus 1 omega C. This is a frequency dependent as well as this is a frequency independent. Okay, at a time omega C minus, and the real time is imaginary time. I am for in order to obtain the resonant frequency, same what you have tell in parallel, I mean series, the resonant circuit omega C is equal to 1 by omega L, that is equal to omega square is equal to 1 by LC. Same omega is equal to 1 by root LC. Omega means 2 pi f, 1 by root LC, whereas f is equal to 1 by 2 pi root LC. Okay, same equation is same for parallel as well as a series resonant circuit. Okay, at a time in this also having a graph like that, it's a frequency along x-axis as well as a gain along of y-axis or current along y-axis. In this we are used to get a graph, I think obtain a graph like this. In between FL over frequency, it is as FH. In between we are having a max. In order to get a cutoff frequency, so that FL, another one is FH. In between center, that is XL is equal to XC. Nothing but this is known as dB. In terms of dB, we are using to calculate at minus 3 dB. Nothing but it is called as cutoff frequency. Nothing but it is maximum. It is derived as a maximum gain by root 2. Okay. Before LF, it acts as inductive. After FH, it acts as capacitive. Nothing but the bandwidth can be determined as FL minus FH. It depends upon two factors, quality factor, another one is bandwidth. Nothing but quality factor means maximum energy stored in an inductor as well as maximum power, maximum energy dissipated, that is equal to V into L divided by V into R. It can be written as IL into L, nothing but IL into R. Both current can be cancelled. L can be written inductance of inductance, XL. XL also can be written as omega in terms of omega L. That is quality factor is equal to omega L divided by R. Whereas bandwidth can be written as delta F, F2 minus F1. Okay, this entire are been circuits in are been used in different applications. First one is filter circuits. Another one is tank circuits. Another one is in between antenna. For antenna tunable, it can be also used. It require low power requirements in order to construct the above circuits, whereas small in size. This is the advantages are about parallel resonant circuit. Okay, this is about series as well as parallel resonant circuits. In this LCR series, LCR parallel, the frequencies are been same, whereas quality factor are been different, whereas bandwidth are been same. That's about series and parallel resonant circuits. Both are, you can write the differences in the series as well as parallel. It acts as an acceptor circuit. It acts as a rejector circuit. It allows maximum current flow. It allows minimum current flow. In this, impedance is minimum, that is Z is equal to R, Z minimum is equal to R. In this, impedance is maximum, admittance is maximum, admittance is minimum. Both in this we are using reactance of an inductor and reactance of a capacitor, so that the energy can be stored in this device. Both are used as tunable circuits for selecting the frequency. Okay, thank you.